Let us begin this session with an activity. A boy is participating in a race where he has to collect the balls placed on his track. He has to collect one ball at a time and return to the starting point, drop the ball, and then go for the next ball. We will see for each ball what distance he has to run. For the first ball, he goes 6 meter, receives the ball and return back 6 meter to the starting point. So for collecting the first ball, he has covered a distance of 12 meter. Similarly, he goes for the second ball. This time he has to run 6 plus 2, 8 meter, and return to the starting point again 8 meter. So for the second ball, he has to run 16 meters. Next, he goes for the third ball. He runs 6 plus 2 plus 2, that is 10 meter, and 10 meter to return to the starting point. So total of 20 meters for third ball. Similarly, he goes for fourth, fifth and sixth ball. So for the last ball, he has covered a distance of 32 meter. We will be focusing on these numbers to study the arithmetic progression. Let us represent these numbers on a number line. The interesting thing about this set of numbers is that the difference between any two consecutive numbers is a fixed number, that is 4. In other words, if I am starting with a number 12 and if I want the next number in the list, I have to add 1 times 4. If I want the next number in the list, I have to add 2 times 4 to the first number 12. Similarly, if I want the next number, fourth number of the list, I have to add 3 times 4 to the first number 12. The next number is 4 times 4 added to 12. I think you must have guessed it correctly for the next number in the list. If I want sixth number, I have to add 5 times 4 to the first number 12. So you can see that whichever number I want starting from the first number, I have to add 1 time less the fixed number. Suppose if I generalize this, my first number or the first term is A, and each time I have to add a number D to get the next term, then my second term will be first term plus 1 time D. My third term will be first term A plus 2 times D. Similarly, my fourth number will be 3 times D added to the first number A. Fifth term will be 4 times D added to the first number A. Similarly, the sixth term will be A plus 5 times D. The list goes on in a similar pattern. Suppose if I want 28th term in the list, then what I have to add? Yes, I have to add 27 times D to the first term A. So in general, if I want any term, say for example nth term, then I have to add n minus 1 times D to the first number A. So a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term is called arithmetic progression. Here the fixed number is called common difference. So the general term of an arithmetic progression an is given by the formula a plus n minus 1d, where a is my starting number, that is the first term of the AP, which can be any real number. It may be positive, it may be negative, it can be rational, it can be irrational. Then d is the common difference which I am adding to get the next term. Again, d can be any real number. Then n is the number of terms in the given AP, that is the counting of the terms, so it can be any natural number. And an is the nth term of the given AP. For example, 6th term, then it will be a6, 7th term, then it will be a7, 28th term, then it will be a28, and so on.
So now we have seen what is an arithmetic progression, how the terms of an arithmetic progression are obtained. It's time to solve questions on that. The first question is, show that the progression 10, 6, 2, negative 2, negative 6 is an arithmetic progression or AP. If it is an AP, write down its first term, common difference, and find its 10th term. So to check whether the given progression is an AP or not, we have to find the difference between consecutive terms. So the terms of the progression are 10, 6, 2, negative 2 and negative 6. So we find the difference, second term 6 minus first term 10, that gives negative 4. Similarly, we check third term 2 minus second term 6, that is again negative 4. We need to check the difference between the two consecutive terms for all the terms given in the question. So the next pair of consecutive terms are negative 2 minus 2. So that again is negative 4. And the last pair is negative 6 minus negative 2. So that gives negative 6 plus 2, negative 4. We need to check the pairs of consecutive terms, the next term minus the previous terms, for all the given terms. And once we identify the difference is seen, we can say that the given progression is an AP. So if it is an AP, we can find out the first term, that is A, is given in the progression 10. Second answer, that is we have to find the common difference. So that we have already checked, and the common difference is negative 4. And the third thing that we need to find is 10th term. So we need to find T10. So in this formula, we have the value of A, we have the value of D, and we have to find the 10th term. So we have N is equals to 10. So we have the value of all the three terms in the formula. So we apply in that formula 10 plus N minus 1, that is 10 minus 1, 9, multiplied by D, that is negative 4. So that gives 10 minus 36. So the 10th term of the given progression is negative 26. So this is how we check the progression for an AP and then find the required term. Another question is, find the nth term of an AP 5, 11, 17, 23. Now here it is already given that this is an AP. So we can identify A as 5. To find the difference, we need to subtract the term with its previous term. So D we can find with second term 11 minus first term 5. So that is 6. And then using this formula, we have to find 11th term and 21st term. So first we have to find 11th term T11, where N is 11. So if we use this formula, we get a plus, that is 5 plus n minus 1. N we have to find 11th term. So n is 11. So 11 minus 1, that is 10 times the difference that we have found out as 6. So 10 times 6, 60 plus 5. So the answer of 11th term is 65. Similarly, to find 21st term, we use the same formula and replace n by 21. So we get 5 plus n is 21. So 21 minus 1, that is 20 times d is 6. So 20 times 6, that is 120 plus 5. 125 is the 21st term of this given AP. The next question says, how many terms are there in the AP 41, 38, 35 up to negative 1? So we have to find the number of terms in the given AP, where we are given with the first term, that is a equals to 41. We can always find the difference when the AP is given. The difference is second term 38 minus first term 41, and that is negative 3. And now here the negative 1, which is given at the end of the progression, end of the AP, that is our last term. So that is Tn is given negative 1, and we are asked to find number of terms. So that means we have to find n. We use this same formula and replace all the values that are given in the question. So Tn is negative 1 equals to a plus, that is 41 plus, now we don't know n, how many terms, so we keep n minus 1 as it is, multiplied by d, that is difference is negative 3. If we transpose 41 to the left hand side, it will become negative 41, and negative 41 minus 1, so negative 42 equals to n minus 1 times minus 3. Now we transpose this negative 3 on right hand side, it will go as the denominator. So negative 42 upon negative 3, that is n minus 1. So on simplifying this, minus and minus will get cancelled. 3 1 times and 3 14 times. So 14 equals to n minus 1, that gives n equals to 15. That means there are 15 terms in the given AP. The next question is, which term of the AP 3, 8, 13, 18, 23 is 98? So this is very much similar to the previous question that we have solved. The first term of the AP is given 3. The common difference in the given AP, that is 8 minus 3, is 5. And we have to find the number of term of 98. 98 is which term? So let's say if nth term is 98, we represent Tn equals to 98, where we don't know n. So again, we have to find the n. So substituting all these values in the formula, Tn, that is 98, equals to 3 plus n minus 1 times 5. So transposing 3 to the left hand side, 98 minus 3, that is 95, equals to n minus 1 times 5. Then transposing 5 on other side, 95 divided by 5, that gives 19. So 19 equals to n minus 1, therefore n equals to 20. So that means 20th term of the given AP is 98. Another question is, the fourth term and the 10th terms of an AP are 13 and 25 respectively. Then find its first term, common difference, and 17th term. So we are given with fourth term of an AP. So we write in the symbolic form as T4 equals to 13. And the 10th term, that is T10 equals to 25. We don't know the first term, we don't know the common difference, or in short, we don't know what is the AP, but we know the formula for nth term of an AP. Pn equals to a plus n minus 1 times d. So here we know fourth term is given 13. That means it is a plus 4 minus 1, that is 3d. And 10th term is 25, that means n is 10. So this is a plus 9d. So now we have two equations, equation number 1, equation number 2, having two variables. So we can solve these two equations simultaneously, and here the coefficients of a is same, so we can eliminate a from both the equations by subtracting. So if we subtract, a gets eliminated, 13 minus 25, that is negative 12, equals to 3 minus 9, so that is negative 6d, and that gives d equals to 2. You can use substitution method also for solving these two equations. Once we get the value of d, we can put in any one equation. So let's say if we put in equation number 1, we get 13 equals to a plus 3d. 3d means 3 times 2, that is 6. So a is 13 minus 6, that is 7. So we need to find here the first term, that is 7. This is our first answer. Answer number 1. We need to find common difference, so we got d also. So this is answer number 2. Now we have to find the 17th term of this AP. So we need to find T17. So we can always use this formula for finding nth term, a plus n minus 1d. So a we have obtained 7 plus n, we have to find 17th term. So n is 17, 17 minus 1, 16 times d also we have calculated as 2. So 7 plus 16 times 2, that is 32, and 7 plus 32 is 39. So the 17th term, T17, is 39, and that is our answer number 3. Now this is an interesting question. Find the 8th term from the end of the AP, 7, 10, 13 up to 184. We have to find 8th term from last. So 8th term from 184, which term is that 8th term that we have to find? So in this AP, the first term given is 7, common difference, that is 10 minus 7, always common difference is second term minus the first term. So that is 3. And the last term, we don't know which number is it. So Tn is 184. So first we need to find n, and then counting backwards, 8th term from the last is our required term. So putting in this formula all the values that we have, Tn, that is 184, equals to a 7 plus n we don't know, so n minus 1 times d, that is 3. Transposing 7 on other side, we get 184 minus 7, that is 177, and then transposing this 3 on other side goes in the division, 177 upon 3, that gives the quotient 59. So 59 equals to n minus 1, therefore n is 60. So in the given AP from 7 to 184, there are 60 terms, and we need to find 8th term from end. So if we count backward, 60, 59, 58, 57, 56, 55, 54, and 53. 1, 2, 3, 4, 5, 6, 7, and 8. So 8th term, that is 53rd term, is our required term. But every time it is not easy to calculate the term from the last. So to find 8th term from last, we do n equals to 60 minus 8, that gives 52. But we want 53rd term. 60 minus 8 means 8 terms are removed, but we want 8th term, so we add 1 to get the required term. So our required term is 53rd term of this AP. So T53 is A 7 plus 53 minus 1, that is 52, times D, that is 3. So 7 plus 156, and that is 163. So the eighth term from end is 163. You must be finding this method a bit tricky or confusing. There is an alternate way to find the any given term from the end of the AP. Let us see an alternate method for finding the eighth term from end. We know for this given AP, first term is 7, D is 3, and last term is 184. Now, if you observe and if you see by reversing the AP, if we reverse the given AP, that means the last term 184 becomes the first term, and the first three terms which are given becomes the last three term, that is 13, 10 and 3. So our first term of reversed AP is 184, and if you observe, the given AP was increasing by 3 for every term, every consequent term. And if we reverse the AP, you will observe that every term is decreased by 3. Every consequent term is decreased by 3. So that means D is negative of the original D. So that is negative 3. Now we have to find eighth term from end of the main AP, which is equal to the eighth term of reversed AP starting from 184. So that means simply if we put n equals to 8 in the formula and find out T8 of reversed AP, we get 184 plus n minus 1, that is 7 times D, that is negative 3. So that is 184 minus 21, and that gives again the same answer, 163. So to find any term from the end, just take the reverse AP and make the D as negative of the D in main AP.
Somewhere in the 17th century, a teacher in an elementary school asked the students to find the sum of 1 to 100 natural numbers to keep the students busy. Now, there was a child who came up with the answer very quickly. To see how he got the answer, let us see another part of this chapter. Suppose we are given with an AP 1, 3, 5, 7, 9, and we are asked to find its sum. So we have 5 terms, so we can write that sum as S5, 5 written in the subscript, and it is equal to 1 plus 3 plus 5 plus 7 plus 9. Now this is easy to calculate on fingertips, but we will use this simple sum to find the formula for sum of n terms of an AP. Consider 1 as a small square of side 1 unit, 3 as 3 such squares, 5, 7 and 9 as similar 5 squares, 7 squares and 9 squares in a line. Now, for the simplicity or for a method, we will duplicate this, and hence we get this sum twice. Now, rearranging the second time the sum of 1, 3, 5, 7 in the reverse order, we can see that if 1, 3, 5, 7, 9 is increasing in a particular pattern, then 9, 7, 5, 3, 1 is decreasing in the same pattern. Now, on combining these two patterns, we get that all the rectangles are of same length, and for more simplicity, we can say that all the lengths are the sum of first number 1 and the last number 9. So S5 we can write as there are 5 such columns. So 5 multiplied by each column is of length 1 plus 9, first term and the last term. And since we have taken this sum 2 times, to find the required sum we will divide it by 2. So we get the sum of our given AP as 5 times 1 plus 9 divided by 2. Now let us generalize this formula. Suppose we are given an AP A plus D, A plus 2D, A plus 3D up to n terms, and we are asked to find the sum of n terms Sn. So using the above example, we can write Sn equals to, now we got that 5 by the number of terms. Here we have n terms, so instead of 5 we will write n. Now in that bracket it is 1 plus 9, which is the first term plus the last term of the given example. In general we have first term a and the last term a plus n minus 1d, or for simplicity we will write L as the last term. So n times the sum of a and L and then divided by 2. Or we can replace this L by last term, that is nth term, as an is equals to a plus n minus 1d. So replacing L by a plus n minus 1d, we get n times a plus n minus 1 times d whole divided by 2. Or we can simplify this as n times 2a plus n minus 1d whole divided by 2. So this is the formula for the sum of first n terms of a given AP, where a is the first term of the AP, d is the common difference, n is the number of terms in the given AP. This formula can also be written as n times a plus L divided by 2, provided that we are given with L, which is the last term of the given AP. Carl Friedrich Gauss. He was that student who gave the answer of sum of 1 to 100 very quickly. He was a famous mathematician as well as a physicist.
Now that we have seen the formula to find the sum of first n terms of the given AP, let us solve few questions based on this formula. The question here says, find the sum of the series which is given as 2 plus 7 plus 12 plus 17 up to 19 terms. So this AP is given where the first term is 2. The common difference is 7 minus 2, second term minus first term, that is 5. And it is given we have to find the sum of 19 terms. That means n is equal to 19. If we use this formula, the sum of 19 terms, first 19 terms is n by 2. So 19 by 2 into 2a. A is 2, so 2a will be twice of a, that is 4, plus n minus 1, so 19 minus 1, that is 18, multiplied by d, that is 5. So on calculating this part, we get 19 upon 2 multiplied by 18 times 5, that is 90 plus 4, 94. On reducing, we get 19 times 47, and the answer is 893. So the sum of first 19 terms of this given AP is 893. Next question is similar to the previous one. Find the sum of the given AP starting from 7 10.5 or 10.5, 14 and up to 84. Now here we don't know how many terms, we don't know the value of n. So the first thing is we need to find the value of n, and to find that, let us first write the first term, that is 7. To find the common difference, second term 10.5 minus 7, that is 3.5. You can keep this answer in fraction form also, 10.5 minus 7, so that will be 3.5. And here the last term is given 84. That means it is given Tn as 84, where n is unknown. So using our first formula of Tn, that was a plus n minus 1 times d, we can solve for n from that formula. 84 equals 7 plus n minus 1 times 3.5. This type of sums we have done in the first part of this session. So solving this equation for n, transposing 7 to other side, we get 77. Then transposing 3.5 on other side is 77 divided by 3.5, and that gives answer as 22. So 22 equals to n minus 1. So we have n equals to 23. Now that we have found the number of terms, we can use this formula for finding the sum of first n terms. So the sum of 23 terms given in this AP is 23 by 2 multiplied by 2a, so that is 14, plus n minus 1, so that will be 22 times 3.5. And on calculating this, we get 23 by 2 multiplied by 91. 22 times 3.5 is 77, and plus 14, that is 91. So both the numerators, numbers in the numerators are odd numbers, so we cannot reduce it by 2. So we multiply 23 by 91 and then divide by 2. We get the answer 1046.5. So the sum of the terms from 7 to 84 of this AP is 1046.5. Now in this previous part of this video, of this session, we have seen an alternate formula for finding the sum of first n terms. Once we have obtained the value of n, that was 23, there is an alternate formula to find the sum of first n term, that is Sn equals to n upon 2 multiplied by the sum of first term and the last term. This formula we can use only when we know the last term given in the question. So putting the value over here, 23 upon 2, 7 plus 84, and that gives the same calculation, 23 upon 2 times 91. So the answer will remain still same. The next question says, find the sum of first 15 multiples of 8. We know multiples of 8 are 8, 16, 24, 32, and so on. So the multiples of any number taken in the sequence, they always form the AP. And the common difference is the number whose multiples we are taking. So here, the first term, that is the first multiple, 8, and the common difference is we are taking multiples of 8. So difference is the same number. That is, if we check 16 minus 8, the answer is 8. And we have to find the sum of first 15 multiples. That means n value is 15. So using this formula again, we get S15 equals to 15 by 2 multiplied by 2a. N is 15, so n minus 1, 14 times 8. On calculating this part, we get 15 upon 2 multiplied by 128. So we can cancel this even number by 2, that is 64. So 15 times 64, and that gives the answer as 960. Of 8 when they are added. The answer is 960. The next question says, find the sum of all odd numbers between 100 and 150. So here we are not given with the series, with the arithmetic progression. So first we need to find the required numbers. We require all odd numbers between 100 and 150. So between 100 and 150, so means we have to start from 101 and we have to check till 149. And here if we find that both of these numbers are odd numbers, which is what we require. So the required series or arithmetic progression in this question has first term 101, the next odd number is 103, next odd number 105, and it goes till the last odd number under the given condition as 149. So the first term A is 101. Common difference, since it is odd number, so the difference will be 2. And the last term Tn or L is given as 149. So how many terms are there in this AP? We don't know the value of n. So to find the value of n, we use the first formula Tn a plus n minus 1 d. So 149 equals 101 plus n minus 1 times 2. So in transposing 101 on other side, it gets subtracted from 149, giving 48, and then divided by this 2. So 24 equals n minus 1. That gives n equals to 25. Now n equals to 25, so we can find the sum of these 25 odd numbers as either we use this formula or we use the alternate formula, that is Sn equals to n by 2, first term plus last term, since we know the last term in this question. So 25 by 2, first term 101 plus last term 149, and on calculation we get the answer as 25 divided by 2 multiplied by 250, and that is equal to 3125. So the sum of all the odd numbers between 100 and 150 is 3125. Last question for this session. In an AP, respectively, find the first term, the common difference, and the sum of first 20 terms. This type of question we have already taken up earlier in this session. So given things here is T4 and T6. T4 is given as 8 and the sixth term T6 is given as 14. So applying the formula for the general term of an AP, 8 equals to A plus 3D and 14 equals to A plus 5D. So eliminating A from these two equations simultaneously, we get negative 6 equals to negative 2D. That gives D equals to 3. So this is our second required answer. Find the common difference. So the common difference is 3. Now putting this common difference in equation 1 or equation 2, we will find the value of first term, that is A. So let us put in equation number 1. 8 equals to A plus 3D, that is 3 3 is a 9. That gives A equals to negative 1. So this is our first required answer. Find the first term of the AP. So for the first term of this AP is negative 1. Now we have to find the sum of 20 terms, first 20 terms of this AP. So using this formula, S20 equals to 20 by 2, 2A, that is negative 2, plus n minus 1, that is 19, times D, that is 3. So 19 times 3, that is 57, minus 2, and we can reduce this 2 and 20. So we get 10 times negative 2 plus 57. So 10 times 55. So answer is 550. This is our third required answer. So we have seen the entire concept of the arithmetic progressions. We have solved the questions based on the formulas that we derived for arithmetic progressions. I hope you enjoyed this learning. Thank you for joining the session.